My name is Ángel Cardama. I'm a professor at the Universitat Politècnica de Catalunya, and I'm going to talk about TV SAT, or if you want, direct-to-home satellite TV. We're all familiar with this television service. We've seen around many antennas pointing towards the south to a distant satellite, and we can receive from this satellite a large number of TV programs. This is the view of the new family of communication and broadcasting satellites of the European Space Agency. It's defined as the NeoSat mission, and here you have just an illustration of a satellite of that new family that's going to be launched in the near future. And you have, from the equator, is where is placed the satellite, a certain number of antennas, and the Earth. In this case, you see the continental part of Europe that is close to us. Those satellites have very long solar cells to power the satellite. The dimensions are typically high. This could be 3 by 3 meters and up to 5 meters in this dimension. They have parabolic reflectors of a couple of meters, and the mass of the satellite could be approaching 5,000 or 6,000 kilograms. Half of that mass is for the fuel just to bring the satellite to the orbit and to keep it stationed in there. So we are going to study this case. We are going to propose you to work the following program, the following case. Select one satellite. In this case, we are going to talk about the Astra-1-en satellite that is located more or less on the meridians of Central Europe. It's 19.2 degrees east on the equator. This satellite has a beam that covers all Europe and the islands, the Canary Islands too, and some other places. And this satellite is a powerful one in the sense that it has many TV channels on it. They are all digital now, so there are hundreds of channels involved. It has 55 transponders in this Ku band, which is this frequency band in the downlink, from 10.7 to 1275 GHz. You can find a lot of information on the web. There's no problem for this. And here you have a couple of links to the Astra web page to get information on the satellite and on the programs. Now, every transponder operates at 130 watts of RF power. This is not really very high, although the DC power in the satellite is really high, but that's because it has many channels. So the power has to be shared by all those channels. So this gives a number that is very close to powers we are familiar with. And with this, with a satellite that is 36,000 kilometers from us, we can still receive a useful signal. Now, the gain of the satellite antenna and this power gives you an equivalent isotropically radiated power of 54 dB watts. The bandwidth depends on the channels, could be typically 26 or 33 megahertz. And for reception, there are many antennas in the market. They all have a parabolic reflector, they have a feed, they have an outdoor unit on the feed, and also they have an indoor unit at home. The problem we propose to you is to find the power flash density that you will receive in Barcelona when you point to this satellite and you tune to one of those TV channels. In this case, it's in the transponder number 19 at this time. And this is the center frequency for this channel. It comes with horizontal polarization and occupies a set of 4 or 5 programs that are being broadcasted, a bandwidth of 26 megahertz. This is for the requirement. Now, if you assume that your receiving antenna is a 65 centimeters offset reflector that has at that frequency a gain of 37 dBs, a noise temperature of 100 kelvins, and on the feed you have a low noise down converter with a 1 dB noise figure, and if you have some margins to include, then work there the values that you can receive for your